Welcome everyone to another Toolbox Tech Talk. It's me, your favorite Toolbox Tech Talk host, sometimes called DJ Glenmo, but I've got a doppelganger. And in fact, sometimes we just combine and do it all together. So today is techie stuff. It's a bit of video, looking at some of the things that here at the Smart Energy Lab. I'll just kind of run you through it, but I want to pick up on what I talked about last week, which was all about going off-grid and designing a system for off-grid. Yeah, well, on top of that, we also have a guest, but I'll come to the guest in a minute. Hey, I'd just like to say that a big welcome, everyone. I'm coming to you from the land of the Wurundjeri, and I watched a fabulous documentary, by the way. If you don't know where that land is, it's in the Yarra Valley of Victoria, lockdown land, is like many people in Australia. And I watched a wonderful documentary about the Wurundjeri and their kind of fight to get some land in the early days in the 1800s. And it's wonderful. It's on SBS, actually, so it's called The First Australians. So there's a little recommendation if you want to watch a really excellent documentary series called The First Australians. Anyway, look, I really hope everyone's doing okay. If you're not, reach out to a friend. It is a tough time, certainly for those who haven't been through this before, or even if they have, you might have kids at home, elderly people, you might be separated from a partner or friends. It can be a pretty tough time. And of course, you might not be able to work. So, yeah, I know it's definitely difficult times for a lot of the trades in Australia. So to kind of liven things up, I thought I would give you some content around off-grid design, also EVs and microgrids, kind of things that are close to my heart. And at some point, I'll have my very good friend, Laurie Kane, drop in from Solar Plus. Laurie and I started Solar Plus, which is a solar design software, 10 years ago. And he'll do a little demo on how you can use Solar Plus for designing an off-grid system. It's a kind of precision tool. But look, I like to give you the basic theory, and we did look at it last week, which was just the 6 easy steps to sizing an off-grid system. In fact, anything with solar and batteries. I might just kind of recap that one very briefly for you, just so that you can, for those of you who missed last week, what we looked at. So let me just flick that over. Here we go. And so what you're looking at here is, got too many lights on, turn the light on, there we go, is what I call my 6 easy steps. So we looked at this last week. Any good design always starts with understanding what the load is. And so this is where I do all my kind of work with my client, is finding out what is it that you're trying to design a system for. I mean, they'll tell you stuff like it's a home, it's got 5 bedrooms, we've got a dishwasher. They'll use words like just the ordinary stuff. But actually, to do it well and to keep the cost down, you need to find out more than just the ordinary stuff. You need to know fairly precisely what the load energy per day is. So that's where a customer load sheet comes in. You need to kind of go through some maths to design a system, and generally that means finding out or choosing a battery system voltage. And this worked example went for 52 volts. You've got to allow for the losses in the system, and there's kind of 2 sides to losses in a solar battery system. One side is the load side, so things like the round-trip efficiency of the battery, the losses in the wire, and the losses in the conversion from DC to AC through an inverter. That will then give you an amp hour demand, which we're almost halfway through now, an amp hour demand per day. So this system here is drawing 1,193 amp hours per day. It's quite a big load, 52 kilowatt hours a day. And then we can size the PV. Now, this all depends on what the solar resource is, and this is where a bit more data is required, more than I put on this piece of paper here. You need to know what the peak sun hours for your site is and for the inclination of your roof and orientation of your roof or ground mount system. And that's where software like Solar Plus can do a very good, accurate calculation of that. So in this case, we sized the system up 23 kilowatts of PV. And then we size the battery system. Once again, you need to ask questions like, how many days of autonomy is the customer going to want? That means how many days without renewable energy input, basically running off the batteries all the time. And based on those number of days and a certain amount of maximum depth of discharge, you can calculate the battery capacity. So we went for 3 days of autonomy and 80% maximum depth of discharge on the battery system because we chose lithium ferrophosphate batteries, and that gave us 232 kilowatt hours of batteries. Now, this is a really big system for most homes, so many people could probably bring this down by a factor of 5, if not even 10. Many people can live on quite efficiently on 5 kilowatt hours a day. But that's kind of really the guts of it. So just coming back to me, look, feel free to throw some questions in there into the chat too, because these are live sessions and I'm here to answer your questions. I've got my scribbly pad next to me. I can draw pretty pictures. I've got some content lined up. And I was also kind of mixing it up between stuff that's kind of more general and stuff that's more specific. Now, something that came up for me in an email chain this week was all about understanding what the short circuit current rating of an inverter is. Now, we're talking a solar inverter and the DC input side of that. Now, inverters generally have on their compliance plate what their maximum operating current is, their maximum power point tracking current. But that's not the same as their rating for short circuit. So if you have an inverter that fails and there's a short circuit internally, you need to ensure that the maximum fault current coming from the array plus a 25% safety margin, because we require that, is not going to damage any part of that circuit. So, you can actually have a safe short circuit in a DC, in a current limited circuit like solar panels, because solar panels have a natural current limit, and that's written on their module data sheet and on the compliance plate on the back. So if you know what the module short circuit current is and you times it by 1.25, that's the overload factor. It also allows for higher radiance, which you can get under certain conditions. And you at that point, you're not exceeding the short circuit current rating of the input to the inverter, then all's good. But the problem has risen that many inverter manufacturers who make for global markets, and Australia and New Zealand are one of those niche markets that have some particularly curly standards when it comes to PV arrays. And the standard 5033, which actually I've got a copy here, 5033 is the standard, here it is, that we use in Australia and New Zealand for PV arrays. The 2014 edition, if you happen to have a copy, turn to page 40, table 4.2, and it says right at the very top, it's all about the minimum current carrying capacity of circuits within a PV array, and it refers to this 1.25 times factor. Now, many people thought that only meant the cable, but actually in the very first row of this table, it says minimum current upon which cable cross-sectional area and or other circuit ratings should be chosen. So that and or other circuit ratings. So that would be the plug and socket connection to an inverter's input, or if it's hardwired, all of that is part of that circuit, because it's a loop. Now, that means that the current rating of the input to the inverter has also got that 1.25 times factor applied. So there you go. That's just a bit of clarification. Now, I know that the many manufacturers haven't quite caught up with us. Some of them are actually rushing out now to bring declarations of what their short circuit current rating is. So it's one of those sleeping clauses that hasn't really been enforced. So I just kind of raise it because you might be tripped up through inspection or other by this requirement. Anyway, I'm looking at my my chat window. Can't see any chatters there. Anyone want to say hi just to make sure this is all working? So sometimes I feel like I'm just talking in the blank here, but looks like there's a few people out there in the audience. But yeah, give us a thumbs up, say hi or something, or feel free to just interrupt and ask a question. So that was just a recap that I thought I'd start with. But next up, I had a slide for this example of the short circuit rating of the input to an inverter. So I better just bring that up there because I went to the trouble of drawing it. So let me just cut over to show you that. Oh my gosh, a whole bunch of questions. Okay. Yay. Thank you, Mick, Mickey, Ryan, Ray, Naeem, Mike, Sean. Yeah, great. Thanks. Yeah, Mickey, you did my course. Cool. All right. I feel at home now. I feel I've got my audience with me. That's great. That's great. All right. So I'm just cutting back over to the example of that short circuit current rating. So here we go. Yeah. So as you can see here, I've got, for an example, and by the way, this problem's really come about because modules have busted through the 10 amp short circuit current limit. There used to be always less than 10 amps, and most inverters had, short circuit current ratings of 12 or 13 amps on their input. So they generally were fine anyway with their MPPT range. But now we're pushing these high current modules. Now, here we go. We've got the Longy Solar 435 watts. You'll see some of these in a minute out on my little mini solar farm. And they've got a short circuit current of 11.26 amps. So it's quite a high short circuit current rating. We've got to multiply that, and there's that clause from table 4.2 by 1.25 times, which is going to give us 14.1 amps. So that means that all of that cable needs to be rated to 14.1 amps. Now, that's not going to be a problem for 4mm cable, but, if you're starting to parallel these strings, you're going to have to think about that carefully. And it also includes this part of the circuit here, what's inside the inverter. So there'll be possibly a plug-in socket here. It's too has to be rated for 1.25 times the ISC of the module. So that's where some manufacturers will give you both a MPPT maximum current and a input short circuit maximum current. There you go. So that's that little diagram I specially drew for you. Okay, now I'm just checking out on the question front here. And by the way, I should finish my intros. I just realized we do have a special guest joining us, Laurie Kane. He's just going to drop in probably around about half an hour or 20 minutes or so. And I'll hand over to him for a little while because he's going to talk a bit about software and how that can be used to design. Then we'll come back to me and take more questions and more examples that I want to cover. So yes, Mike, the Solar Cutter t-shirts are for sale. I think if you just go to the Solar Cutters Facebook page, you can buy them from there. They sell all this merch. In fact, thank you, Solar Cutters. They gave it to me, and I'm very proud to wear it. They represent, the quality end of the market in terms of solar installation. So they've always, promoted quality workmanship, and through their Solar Cutters website or Facebook group, a lot of discussion goes on. So yeah, big thanks to Solar Cutters for that. And actually the sunglasses are good. So that's the Solar Cutters sunglasses. They polarized even. Yeah. All right. So now, Mickey's got a question. I'll just throw Mickey's question up here. So, Mickey, you ask, any thoughts on the Huawei Lunar batteries? Well, I've done a unboxing for these. Now, I have a channel, which is where a YouTube channel where a lot of this content gets released. In fact, I'll just bring up there. You can watch my unboxing of it, but it's not a performance review because I only had it for a short time just to, check it out. How does it, go together basically, but we didn't have a system to build. So it's sort of a halfway house to understanding how it works. But I was very impressed by the design of that battery. So the Huawei battery, like many of the residential compact batteries, is stackable. So they come in 2 or 3 high, and you can have, I think it's 2 or 3 stacks, vertical stacks. So you can go up to about 30 kilowatt hours. It's 2 stacks, 3 high. Each battery module is 5 kilowatt hours. So yes, you can actually bring up quite a bit of capacity with them, and they're very thin. If you put it against the wall, it only sticks out about less than 200 mils from the wall. So they're very compact, and they're a high voltage battery in parallel, not in series. So each battery module feeds into the next battery module in parallel, and they have a DC-DC converter that allows them to interface with a range of inverters from Huawei. So they can do their 3-phase inverters, which require high DC input voltage, and their single-phase inverters, they're hybrids. So yeah, it's a pretty interesting product. So thanks for that question, Mikey. And Ray also points out, and by the way, there's some very big numbers out in there. Just a note for you, LG Neon 380 watts, short circuits 10.8 amps. We're seeing some in the 12s now. So, numbers are getting big on current. Basically, it's your large cell size. The bigger the cell, the bigger the current. And that's what's happening. All right. What did I have up next? And verticizing. Oh, yeah. So I've got a bit of a video here, actually. And this is last week I did a little walk and talk. Basically took my phone out and walked around and then showed it. Well, I did it again. This time I went out and it was freezing cold. Anyone who lives in Victoria at the moment will know we're having a bit of a cold snap. We're expecting snow here at Mount Tulibrawong, but it didn't come. So we got all excited. All the kids got their toboggans out and snow gear ready for the first thing in the morning to get out and slide around in the snow, and there's none. But it's still bloody freezing. So I went out there with my camera and filmed some stuff. So apologies for the shaky camera work. So I'm just going to bring it up and talk over the top of this. So here we go. First up is, and here it is the EV charging station that we just completed. Now, we're an off-grid community. There's 70 people live here. There's 30 homes. And up until about a year ago, we just relied on internal combustion engines. But wow, the tipping point has come. And I think first there was one EV. Within a matter of weeks, there was two more. So we had three. Then there was some plug-in hybrids, another couple of those, and then a fourth EV. So we've now got 4 EVs and 2 plug-in hybrids here at the co-op. So because at the Smart Energy Lab, we have a lot of solar, more than we need on a sunny day by a long shot. You'll see that in a minute. It's a small solar farm. We put in some charging stations. So what these are smart chargings. This one is called the SMAPI, and behind it is the Garo. The SMAPI, haven't finished commissioning it yet, but it's got Wi-Fi connectivity or wired Ethernet to the internet. It communicates with some smart modules in the main switchboard, and I'm yet to find out all the intricacies of it, but what it basically does is allow you to prioritize renewable energy as your source of energy for charging vehicles, and you can schedule stuff as well. So we really only want to charge vehicles when the sun's shining, so that's kind of how we're going to use this unit. This is a dual 22 kilowatt unit, so it's got 2 type 1 connectors. There's 10 kilowatts of solar on the roof, which is not the only solar connector. There's about 100 kilowatts on this network, but that's just to maximize the benefit of having a carport. Might as well put solar on it as well. So in the background, by the way, you can see some more cars, or another white car parked. That's the trickle charging station. So we've got some slow chargers for overnight charging. And this is all off-grid. So actually, electric vehicles are very cheap to run. I'm talking to the converted probably, because a lot of people have them now. Certainly from the people interested in solar. Are very cheap to run, and if you have enough spare capacity on your solar system, oversizing is a really good thing, by the way, then you can really dump it into vehicles. Now, this is our mini solar farm. Jokingly, we call it a solar farm. We're just building different trackers at the moment. These are supplied by Architect Solar as a demonstration unit. That's their 1P tracker, 30 kilowatts, basically, 90 meters long. Weather station, which controls their direction. When there's a storm or high winds, they go into the stow position. And they track the sun on a single axis. So single axis tracking, by the way, is very, very popular now for solar farms in Australia. I think 70% of new farms use single axis tracking. It's amazing the flat production curve you get out of them. From early in the morning to late in the afternoon, they're putting out pretty much the same amount of power if it's a clear day. We've got 2 types of panels on this system, by the way. I'll come to that in a minute. These are Longi Perk, so that means they're monofacial. We're looking at the back of them now. And you'll notice that being a tracking system, you also have to have some shock absorbing, some way of controlling wind load. So they've got springs and shock absorbers at intervals along the tracker. That pole, by the way, it's called a torque tube. It rotates. So the whole thing is one 90-meter long shaft. They call it a torque tube that rotates. And it's got a motor driven by PV, so self-powered. The motor is controlled by the weather station, which you saw just earlier on. One thing to consider is vegetation control. Like we've got a bit of bracken here. Now, we are planning to put down weed matting and some pebbles, actually, to stop the growth underneath the panels. But because these are quite low to the ground, they would be quickly shaded by summer growth from that bracken. Now, we're coming up to a change in type of panel. What you're seeing coming up next is the bifacial panels. They're exactly the same power rating. They're 435 watts. I'm just going to pause it right there. They're Longy Solar 435 watt panels. And we talked a bit about bifacial last week. I had some comments from Jennifer. And bifacial actually need to be able to get some reflected light, some albedo from behind to get their full performance, or even just to be equivalent to monofacials. If you put bifacials in parallel to a roof where there's no bounce on the back, they actually don't work as well because they rely on some of that rear irradiance for their full rating. But what happens here is we've got identical arrays, both on the same tracker, and under some conditions, like particularly bright fog, we get significantly more from the bifacials. But always the bifacials are a little bit ahead because of albedo, and depending on what the color of the ground is, that will vary. So, if this was light brown grass, we'd probably get up to like 15% more out of the bifacials. So they're becoming very popular. That's the controller with a little antenna on it, controlling the motor, which is that orange thing. It's actually called a skew drive, I learned. So there you go. So we're going to spin around quickly and look at the other tracker, which isn't complete yet, which is a tall one. Now, you might be thinking, hang on, who's going to put in a great big ground mount system like this? But it's amazing. If you're on a rural property, you're probably going to, and you're trying to put a decent sized system in, you might just run out of roof space. So ground mount actually is starting to become pretty popular if you've got the space for it. And being able to track gives you a whole lot of extra benefits. So this is the 2P tracker yet to be completed. We had a few installation issues. There's the panels ready to go up. So it's 2.5 meters high to the tube. So it's quite a lot higher. And we're not really too crash hot at the engineering side because it was going to be done by a solar installation farm, but because of COVID, we kind of tried to do it ourselves. We got one post out of line, and it means the tube wouldn't rotate. So we're going to have to pull it out and straighten it, put it back in again. So there you go. You might be wondering what the egg beater in the background is. There's a little bit of history. That's a Darius rotor from long ago. It's probably 40 years old now. Never worked really. There it is. It's a wind turbine design that doesn't self-start. And it turned out that it actually used more energy than it generated because it was forever stopping and then having to be wound up again with electric drive to start it spinning. But there you go. We just think of it as a sculpture these days. But it's quite tall. It's about 10 or 15 meters tall. When it rotated, it probably was a pretty scary looking thing. So I'm going to just pan over to another part of the microgrid here, one of the client systems on the microgrid. Now, we'll be talking a bit about microgrids. Now, this is a neighbor's house, and they have a up until recently, all they had was solar and batteries and a backup generator. But then they recently connected onto our microgrid, which is where those solar farm panels connect in. And they can now use that in lieu of a backup generator. So they can share, or we can share energy basically amongst 7 homes. Each of those homes have their own solar and battery storage system. So this is one of the things you can do if you happen to have a common property. You can't distribute energy across property boundaries in most states and territories in Australia, but if you're on a common property running and you're close to each other, it's not a big deal. So these houses would be within 20, 30 meters of each other. Another thing that's a bit trivial, but I just thought I'll show you the garden. Food production actually is an important consideration when you're living off grid, and certainly in these difficult times. But boy, wintertime here when it's just about snowing, there's not a lot going on. So kale really rocks in this sort of climate, but everything else looks pretty dead. But keeping the wombats out, that's what the corrugated fence is for. Wombats are awesome at digging. So iron goes down into the ground, and there's this heavy mesh horizontally out from the iron to keep the wombats out. there you go. So a little bit of garden trivia. Now, this picture is the other end of that solar farm. So what you were looking at before was some panels out in the paddock, and there are 4 arrays out in the paddock, 2 per tracker. And they come back to these Select Sun solar inverters. These are 20 kilowatt Select Suns. Now, the purpose of these is to feed into the microgrid, peak power. But because we've got a fairly substantial amount of power coming off the array on a good sunny day, these are controlled by comms, by the battery system that stores the energy. So we've got a electronic power chain system that stores the energy, and it's controlling the output of these Select Suns. So it's pretty important so that you don't overcharge your batteries. So we'll talk a bit about AC coupling with some more diagrams in a second. I just thought I'd show you the physical nature of it. So there you go. That's basically 4 20 kilowatt inverters on the side of the shed, and an EV trickle charging station just in the bottom left-hand corner there. Now, lastly, I'm going to show you once again where the energy ends up on the microgrid, which is a large electronic power chain system and Power Plus Energy battery storage. So I'll just jump forward a little bit. There we go. So that's the power chain, which is 2 inverters per phase. They're actually only 5 kilowatt inverters. We sort of just grew from 1 to 3 to 6 as this is a test system, by the way, from for Electronic, where they do some of their beta software testing, but we can benefit from it. And it's really good. And down the end there is a AERL charge controller. So that's kind of the full suite of the video today, just to show you around the Smart Energy Lab, one of the systems here. So I'm just going to stop that video and come back to me. Where am I? There we go. Turn it off. Okay, I'm just going to check the chat, see what's come in. Yeah, Ray, you bet. Are you going to get a Cybertruck to use more power? It does actually kind of appeal to me. That's kind of the Cybertruck, but I don't know if they'll ever come to Australia because of our road rules. They've got no mirrors. Maybe they'll stick some on, but anyway, we really are entering the time of the EV. So there's so many coming soon. There's a few, not nearly enough, but there's a few models, but not many in the sort of ute market. But there's quite a few EV utes coming, which is kind of what I'd be interested in, something that can carry a fair bit of stuff. We've just got a little Kona, which has awesome range. It's great for a city runabout, but yeah, if you want something that you can use a bit more off-grid, it's a bit light on for that. Okay, so let's have a look what's next up in my drawings. Now, actually still on the front, talking about EVs, is we sort of had this problem, which was when it's sunny, we have heaps of power, but often the EV's out. So people are out, doing shopping or going to work, and then they come back and they want to charge, but the sun's gone down, and we actually have a relatively small amount of capacity on the microgrid for nighttime charging. It's 60 kilowatt hours, but that's got to supply, multiple houses at nighttime if it's winter, for instance. So what we put in was a dedicated EV trickle charging system. So I'm just going to show you that now. Just cut to that. Here we go. Another one of my drawings. Okay. And after I've shown this, I'll pass over to Laurie. I can see Laurie's in the green room. Hi, Laurie. And so what you're looking at here is this represents the microgrid over here. So I'll call this the microgrid. And connected to it are 2 Ingerteam inverters connected in series. Well, actually, technically they're in parallel, but the output of one feeds the input of the next. The reason for that is to get more power. So each of these can deliver 6 kilowatts, and putting 2 of them one after the other means that they can parallel with the first one, parallels with the second one to give twice the output power to the dedicated socket outlet for charging electric vehicles. So the benefit of this arrangement is that there's a little contactor here, that's it there, which is controlled by the master inverter A, and it says when the battery system is depleted, don't use microgrid power, just turn off the EV charging socket outlet. So it means you don't have to worry about draining the main microgrid battery by leaving the vehicle plugged in overnight. It'll just discharge these two battery systems, which is 10 kilowatt hours each. So it's about 20 kilowatt hours of battery storage between the two inverters. And when they're depleted, it'll turn off the electric vehicle. So that's a nice little system. And thanks to Fred from 100 Up. So he's the Inga team guy here in Australia, and also Ned from Pylon Tech for supplying the equipment for this demonstration. I think we've got something pretty exciting coming from both of them soon too. So I'll talk a bit about that when it arrives. But I can see Laurie's just wetting his mouth at the moment, sort of ready to have a bit of a chat. So I did say that we were going to talk about using software for design, and I've given you sort of like, the raw calculations that I would use. But, if you do this for a job, you don't want to use a pencil and paper and a spreadsheet. You want to use software. And so that's what Solar Plus can do. So I'm just going to bring Laurie on. Are you ready? Give us a thumbs up if you're ready, Laurie. Yep. Okay, cool. There we go. G'day, Laurie.
Hey, Ben. How you doing?
Good. I'm adjusting microphone there. Right.
Hey, good on you, Glenn, for doing all of these sessions, sharing lots of useful information, getting out there with it. It's really good. Nice way to spend a Sunday, Harvey.
Thanks, Laurie. I must admit, I never intended it to be my every Sunday, but it has been for over a year now, my every Sunday. Yeah. My kids sort of roll their eyes and go, oh, Dad's doing his thing. He's put his bling on again. Okay.
You've maintained the commitment. That's great. I like it.
So, Laurie, tell us a little bit about Solar Plus and and you're going to throw a demo up in a minute.
Yeah, sure. So Solar Plus, we've been developing this software for almost 10 years now, and it's come a long way from an original idea of a time saver, mainly for system generation, system manual generation, and also just trying to get a best practice design tool into people's hands to do exactly what you said. Make the get the pen and pencil and calculator and Excel spreadsheet out of the picture. Make things smooth and simple, so that people can focus on what's really important, which is the conversations with customers and just getting a good job done by the install teams. So it's come out. It's extended into a very sophisticated quoting tool covering a lot of different design scenarios, including off-grid. And it's one area where it can tell you a lot about the results for a system. So you've got the effects on a generator. So how much are you going to rely on a generator once you've got a system installed? And so, let's maybe just go through an example so you get a bit of a sense of what you can do. I'm not sure if I can.
I'll bring your screen up. Hang on. You ready?
Yeah.
And there it is. And go. And I'll just drop myself off so I don't cover up too much of the screen. Here you go.
Yeah, so let's just go through a scenario. We've just come into Solar Plus here, and on the dashboard we can see quotes that we're working on and where they're at. But here we're just going to zip through a quote, and this is for Kettle. And I'll just drop the address in. We Road. And as we've got the address, pulling the site map in, we can have a conversation with a customer if they're on the phone about where where they live, what the conditions are. Have they started building? Is this a new site? What's the scenario that you have to work with here? While you're at it, you can see what your travel time is to get out there. Maybe talk about getting out for a site inspection. When you do that site inspection, you've got an area there, a site survey area that makes it nice and quick to capture all of the details on site that are going to be handy during the design process, but also in just preparing for the installation, making sure that you've got everything covered off. Now, we're in a quote workflow here, and we've come through to the energy assessment part of it, and we've got an energy costing and consumption profile. So since we're looking at a off-grid scenario, you might notice that I've already got a tariff pre-filled here and a consumption profile pre-filled for a more basic on-grid scenario. But here, I think what we'll do is we'll look at a scenario where we're comparing with grid connection. So there's two options in terms of the modeling of off-grid systems here in Solar Plus. One is where it's diesel displacement, or comparing with the cost of running a generator, and so that might be relevant for a mine site or something that's in a remote area where they have just had generator supply. So you can do that very easily, but in this case, let's just have a look at the scenario where the alternative is connecting to the grid. In this part of it, we're just going to look at what the customer's backup generator might look like and what it might cost. So I'm putting in a 7 kVA generator. There is some default values here to make this easy. But if you know the fuel consumption or approximate fuel consumption of a generator that you may be supplying or they may already have, you can put in that fuel consumption. There's a generator efficiency there that's set to a default power conversion, which is a kilowatt per litre conversion for the generator. It's a fairly standard thing that you wouldn't have to change. The diesel cost, you may be varying this based on the outlook. And an important part of it is genset maintenance, and just considering and factoring in that maintenance cost. Now, at this time of the year, there's a lot of people that are going out to sites to help people keep their systems online. And as you and I know, Glenn, that's an important part of off-grid living at this time of year, where we have a few call outs going on, don't we, to keep our systems online and keep those generators running. I know
I had to drop back in. Yeah, thanks for that. Actually, Laurie's partner, and who's an electrician who does some work for me and for Solar Plus, saved the day because we had a generator failure here, and it's a lot of rewiring to keep the power going. So yeah, the winter time can be pretty tough. Hey, Laurie, we've got a question already. I just might interrupt you for a sec. Sure. You're probably going to cover this anyway. But Ray asks about the imagery.
Yeah, we'll slip through to the imagery options in a sec. So I've got a generator costing here, so I'm just going to save that, and we'll get over to the imagery in just a second. I'll explain the options for that. By the way, I had generator issues this morning as well, but luckily it was just a low oil situation and easily rectified. But it raises an important thing, with off-grid energy systems. There's a big conversation to be had, and one of the things that we try to do with the proposals that we generate in Solar Plus is give as much relevant information as possible so that we're supporting a good conversation, covering all of the things that you might want to bring up with the customer about their decision, and you're building the relationship, but also making sure that they're well informed and are going into an off-grid living situation, perhaps with their eyes open. And inevitably, when, let me just select a consumption profile here. So in many cases, you might want to set up a spreadsheet in Excel where you are doing those, some of those calculations for peak demand and just getting a good idea of what's going to happen. But in here, we can have a few scenarios covered with our consumption profiles and have a full year profile pre-built. So here I can see a weekend and a weekday, but I can build a 7-day profile, put in the monthly kilowatt hour values, and generate a full year consumption profile very quickly and easily as I have a conversation with a customer. But here you can have them preloaded so that you've got that starting point and don't have to think too much about that. One thing that
can I jump in here? So I just wanted to make the point that having that real consumption profile is the next step up from what I was talking about earlier, where you just look at the kilowatt hour per day demand, but it really matters when that demand occurs. If it's occurring during the daytime when you've got solar, that's self-use of solar, but at nighttime it's batteries. So it really helps with more precise sizing of your batteries. So yeah, that's a big plus of using consumption.
I've just come back for one thing that I just forgot to do there is consider the electricity connection fee. So this can be a huge cost for someone who is setting up in a remote location. Let's just put in a figure of $20,000 for a grid connection as the alternative. So what we're looking at here is a rate plan that they may be on, and we're including that connection cost in our analysis to give a more informed picture of where they'll end up with in their grid scenario versus their off-grid scenario. Now remember that you have the option of just a diesel displacement modeling if you're wanting to do it that way. So having come through here to the map, let's talk about mapping options. And this is just Google Map that we default to here, but you can see I've got a few options here. Maybe some people tuning in from New Zealand. We've got recently added lens maps in New Zealand, so there's some really good photo map coverage in many areas and many of the metro areas around New Zealand. So you do have that alternative to Google Map for something better. And Nearmap can be plugged in. So if you've got a Nearmap subscription, you simply add your API key in the back end and you can get that Nearmap imagery. We also have a partnership with Metro Maps, so you can package, bundle up Metro Map license with Solar Plus to get that better imagery. And here we've got pretty good imagery, and as you can see, the color and the definition is pretty good. Now, in this case, we've got someone who's added their tennis court. They've added a swimming pool. It's a pretty classy hobby farm. So let's just think about where we want to put the solar here. And one consideration with off-grid is if you can get some early morning charge going on, that's going to be of benefit. So in this case, I would consider that that east-facing surface to be a useful one for one of our arrays. Now we can have a complete package all ready to go here, and that's what I'm going to do. I'm going to select a system that's 12 kilowatts of solar and 20 kilowatts, I think, of storage. And you never regret having a bit of extra solar when you're off grid, and the cost isn't too great. So it's worth just having that.
Actually, Laurie, can I once again interrupt while you're doing that? So just want to pick up on your east-facing array comment. So with off-grid, you'll often be at your low ebb, certainly in wintertime, first thing in the morning, and you really want to get some charge into the battery system or to supply the loads. So that east-facing array is kind of your kickstarter for the day. There's actually a question that kind of relates to this too, which is from Colin. Colin asks, are there many people, if any, that you know of who have an off-grid system without a backup diesel generator, or is this a situation that just isn't quite feasible? I understand that it would be a big risk to go fully renewable. Just wondering. Well, absolutely. I think I answered this directly to you on the LinkedIn. But if you're prepared to go dark, i.e., you use too much power, the lights go out. Yes, you can be generator free, but the caveat is that will that system charge itself again in the morning? Now, if it's an AC coupled system, it depends. Not all AC coupled systems are capable of what's known as black start. That means once the battery turns off, can they even be charged again from an AC coupled solar? But if you've got a DC coupled system, it'll just charge the battery without you doing anything. So yeah, it kind of depends on the design a bit. Back to you, Laurie.
Yeah, so one thing I'll point out is that we've got a quick guide here. So when you have plugged in your consumption profile and you come through to do a design, it is giving you a suggested solar and battery size. And in that solar size, there's an allowance for battery charge. And you can select the hours of storage in order to estimate the battery size you're looking for. So here, if I go to 24 hours of storage, I'm looking at 37 kilowatt hours. So I'm going to switch from the map view just into a back-end view where we've got some more control setup and configuration of the battery system. You can see in here, this is an off AC coupled system with SP Pro and Power Plus Eco batteries. And we've got 32 kilowatt hours of storage in this case. For an off-grid system, it's fairly generous size, and many off-grid houses will be run very efficiently, but you'll have some people that have higher expectations and they have the money to put into a system that is going to serve them well for their pool and accessories. Maybe a bit of floor heating, Glenn. So again, it's important to have those conversations with the customer about their time of use, what their choices are going to be when they get up in the morning, what time they might want to think about turning on that dishwasher or washing machine. So having come through to the reports page here, and I'll just
interrupt. I think this is kind of where people get to understand this at more of a consumer level, is these graphs and this representation. So up until this, it's been quite technical. So it's more the designer's area. Now you've got something you can show to a customer that kind of makes sense to them. How much is solar? How much is self-use? How much is non-renewable?
Yeah, and to be able to just go through with the customer with the cues or the graphics that help to make those values meaningful is really valuable. Whether you're doing it in person or sending through a proposal and then talking them through it over the phone and talking about that, you might be or may not be showing them the solar production and how much of it is actually unused, because that's kind of might be a conversation that you want to have, and it may not. But definitely having that headroom in the battery, on the solar side of things for winter charging is so important, and we can see that in another chart.
I know, I mean, with low feed-in tariffs across Australia, many people are spilling energy back to the grid for little or no benefit. They may even soon be charged to spill it back. So, you know, it's no different off-grid. If you don't use it, you lose it. So I like to think that oversizing is your discretionary use. Certainly in the warmer months or the sunnier months, you end up with a lot of discretionary use of electricity. You might even have like some services change during the summer months. You might be using, you know, wood heating or wood cooking or even nasty gas in wintertime, but then in summer you use electrical heating and cooking and cooling.
Yeah. So this chart I love for the month-to-month variability when it comes to off-grid and being able to see compare, for example, the solar supply per month against the consumption, against the generator, and the generator runtime. So being able to get that visual of the generator use through the year is super valuable. And all of these charts you export, you can bring them into Excel when you want to dig in and play with the values in them. And here we've got a daily performance chart where, again, we can drop out some of those values to break it down and support that conversation with the customer about when a battery is charging, the state of charge, the battery discharge, and when the generator comes into play. And when you're thinking about that generator runtime, it's great to be able to drill down to see the day-to-day variability, because it's all very well to look at averages, but it's so much more meaningful when you're getting to see it on a day-to-day basis with a detailed simulation. So I'm going to just drill in here. While we're doing that, I can see that in May, we've got the minimum average peak state of charge. So that gives us a heads up. We can kind of go in and see in this location, what's the weather doing? Is there a lot of rainy days at that time of year? And being able to get a picture of what happens when the solar starts to drop off, when the generator's called, is great for your sizing to begin with, to consider how much solar you want to build in and oversize for those winter months. And so with this chart, you can go week to week and go right through any time of the year to see how it's performing.
Hey, Laurie, another question kind of related to this from Ray, Ray's an absolute regular on this channel, by the way. Great, thanks for tuning up, Ray, and asking some great questions. So Ray says, is there an option by postcode for the design side? He sort of goes on to a second question, say, for how much solar is average for a postcode? Now, postcodes vary tremendously. In fact, if you're in Western Australia, there's some postcodes the size of small European nations. So it's not granular enough, is it, Laurie?
That's right. Yeah. So there is a lot of variability, and with an online system like Solar Plus, we're pulling in weather data at a very localized level. So as soon as the address goes in, we're pulling in solar radiation and weather data for that site, and the radiation data is a 10 square kilometer grid across the globe. So anywhere in the world, we can do the modeling for that site using localized radiation data and the closest weather station. So we pull weather from the closest weather station that's had some reliable weather data for a few years. And yeah, it is important to to work with things on a localized level, and not just, there are a lot of systems around that just rely on some state figures or very few figures that are contained in ground-based data. I've just switched down to the next section of this reporting area where it gets into the month-to-month savings. Now we can see here in gray what it would cost before. So this is the grid scenario where they're paying their bills, and so this is the monthly cost through the year. And then we can see in the after scenario, the off-grid scenario in blue, that's the generator cost, and so that's the running cost then, if you like. Then we can look at that in a payback chart and see some of the main payback metrics in it. Now, let's just consider this for a second, because it's going to come down to the next chart here, which is a cash flow. So this is showing us an important part of the equation when it comes to the question of connecting to the grid versus going off grid, where we can see that grid connection included in the first year, along with the bill charges for grid power, next to the investment cost for their off-grid system. And so here we've got a almost $50,000 system. It's not cheap, but it wouldn't be cheap connecting to the grid. And we've just allowed 20,000 in that grid connection scenario. It can vary widely depending on the proximity of the grid supply that they're looking to connect to. So when we take those that grid connection fee into play, that's going to make the difference between a payback time of around about 16 years and a payback time of 10 years. So it's a big factor, and being able to model it and present it to the customer and explain the options for them is really valuable. You're providing a valuable service to them, and hopefully they'll appreciate that and take you on as their advisor and installer as a result.
I think your connection cost there, certainly for this area, is quite conservative too. So, 23,000 is a fairly low figure. You probably have to have capacity in the transformer already, the house close to the road. And of course, there'll be the reticulation from the point of connection to the house as well, which, depending how far that is. So, sometimes that the payback is day one.
Yeah, and you might be financing a system too, and in that case, you can show a stacked cash flow chart that shows them the immediate savings in year one and the savings over each year, which is a great way to present that too. And in that case, certainly for diesel displacement, where you're talking about off-grid industrial site, their fuel costs and generator maintenance can be very high, and so there can be great savings in those cases as well. We do have a off-grid proposal built into Solar Plus, so it goes through the scenario to, as I mentioned, help guide the conversation. So you can send this through, jump on the phone to the customer once they've had a bit of a look and talk them through it, explain what these things mean. You're able to talk about the percentage coming from the renewables, the remaining reliance on a generator, and what that means in terms of costs and running time for that generator, and then talk them through the cost benefit analysis. And it includes some of the environmental benefits of it too. So you can talk about the CO2 reduction equivalent in cars off the road or trees planted, however you want to present it. So this is just a sample proposal, but any customer anyone using Solar Plus can customize this report to however they want to present it.
Cool.
Then you
hey,
have
a couple more questions. Maybe we can cover these too. This one is from Yariv. G'day, Yariv. I presume he's still in New Zealand. I've met you long ago. He asks, hi, Glenn, any pumps on site? Now, he's referring to the Smart Energy Lab, how to deal with surge currents with all those smallish inverter charges. How does Solar Plus deal with surge demand?
So there's calculations built in for generator sizing. And so you can just put in a generator size and it will just do an analysis to assess whether that is adequate. And it just indicates from the consumption profile that we've put in the peak demand on the genset. In these cases, though, we are talking often about a consumption profile that's built without existing data. So it's a bit different from a situation where the customer's on grid and you can just get that that consumption data, although in some cases you may have consumption data, in which case you can just upload it. For the grid sizing, we can factor in a generator load factor, and so that might be something like 70%. So this is the usable power rating in relation to the generator nameplate rating. So a common value, default value for that would be 70% as a load factor rating. When it comes to surge, though, it is something that's not really calculated within Solar Plus, and so it's something that you might want to do in an external Excel spreadsheet where you've just got some ability to stack up some of the appliances that may be in use at any particular time to consider that and factor that in.
Yeah, I often say that you should clarify with the customer what the surge demand limits are for the system. Like if they say, I want to be able to turn everything on and not worry, well, you just say, more dollars, please, because you put a bigger inverter in. But it doesn't really make that much sense because it's almost impossible to turn everything on. So, identifying what the coincidental maximum demand is, things that were likely to come on together, such as water pumps and devices that use water, like washing machines. So, being more economical in your specification, that's kind of a little bit outside of what we're talking about here, which is sizing solar and batteries. That's actually thinking about how the customer operates their system. Hey, Laurie, there's one more, which I think you're going to touch on, which was the mapping options. Did you mention the different mapping options available? Oh, you did. Sorry, I wasn't listening.
I did, yeah. So,
do you want to bring that page up?
Yep, Google. I've just swapped tab. It doesn't seem to have followed me there. Just a second. I'll just switch over to map view so we can take a look at that again. So we can see the map options available for this scenario here from Google, near map, metro map. This one is New South Wales, so we've got New South Wales 6 maps, and there's a SA government mapping in there for people in SA. So in this case, even though this is a remote site out around Orange, there's actually 4 mapping choices if you chose to use them all. 2 of them are paid, 2 of them are free.
Yeah, some of those state mapping services are really quite impressive for a free service.
Yeah, and the New Zealand one, Lynn's Maps, fantastic. Some really good imagery there that's free and now included in Solar Plus. So we're really happy to be able to provide that.
And there's always the drone option too. Take your own picture.
Yeah, and there's some places where the state mapping services just don't allow others to connect to the mapping service from through an API. You might have a browser where you can go in and view that maps, and this is the case with Queensland Globe. You can use Queensland Globe and grab the imagery and download it and bring it into Solar Plus, but we're unable to connect directly to that Queensland Globe imagery, unfortunately.
Cool. Hey, Laurie, we're sort of at the top of the hour again. We always seem to run out of time with these shows, but did you cover what you wanted to?
Yeah, sure. So one thing I will point out is that for off-grid commercial sites, you're able to now calculate row spacing for tilt frame systems. We've got some 3D imagery of tilt frame systems coming online soon. And so it's getting really powerful for those commercial situations and off-grid included. Yeah,
great. Well, thanks very much for taking some time off on a Sunday to talk to my audience and me. That was really good.
Thanks for inviting me, Glenn. You're welcome.
And look, I'll put in the description where you can go to the Solar Plus website, but it's a really easy URL, solarplus.co. That's what we're sending them to? Yep. And there's the usual social media pages as well.
Yeah, get in touch and one of our guys can take you through a demo, show you what it can do and see whether it's good for you.
Cool. All right. Well, thanks very much, Laurie.
Cheers, Glenn. Thank you.
See ya. Bye. Yeah, well, okay. Well, there you go. So, like I said, that was just taking you today from how to use a pencil and paper and a calculator through to using some software. There's, horses for courses, to coin a phrase. So now, just looking through the questions here, I think we're pretty much done for today. I actually had more content, but we've been going for just a bit over an hour, and I'm trying to keep it around the 1 hour mark. So I think I'm going to do a third session on off-grid design because I wanted to spend a bit more time talking about microgrids. So that I didn't really kind of get onto that fully. I had actually a bunch of slides here I'd prepared for it, and also a bit about where can you put batteries in an off-grid system, because AS/NZS 5139 have made it more difficult to locate batteries in a residential installation. Not trying to be, difficult, but it is more difficult because of safety. So we're going to have a bunch of considerations about where we can put those batteries. So just in terms of finishing up for today, I just want to thank everyone and, for turning up as you do for these Toolbox Tech Talks. Also, thanks, Laurie, for turning up. And I'm running a course. If your business has batteries, I'm running a battery standards crash course. It's 2 4-hour sessions. I run them on the 11th and 12th of August. So that's 4:30 p.m. till 8:30 p.m. 2 sessions, one day after the other. They're recorded, and so if you can't attend them live, it's done as a Zoom meeting. So people actually interact directly with me in a Zoom meeting. It's not through like I'm doing now through streaming. It's done through Zoom, and you can watch those recordings as many times as you like after the event. Quite a lot of people don't even turn up live and just watch the recordings. So the battery standards crash course, you can find the enrollment for that on my website, solarquip.com, and I think I've even got a caption for that somewhere. No, I haven't. You can also follow me on Twitter. I don't get a lot of tweets, and Instagram with a few happy snaps of batteries and inverters. But most of my content you'll find, and there's absolutely heaps of it, on my Smart Energy Lab YouTube page. So feel free to go over there and to watch more free content. So once again, thanks everyone, and we're out. See ya.